The cosmos hides secrets that defy all logic. We are setting out on a journey to uncover 30 of the strangest things ever found in the universe, from gravitational monsters that pull entire galaxies to signals from the void that have never been explained. By the end, your view of reality will be fundamentally altered. We will confront a star that behaves like no other and an emptiness so vast it should not exist. What is the one cosmic mystery you find most compelling? Our journey begins with a force so immense it commands the motion of our entire galactic neighborhood. Deep within the Centaurus constellation, hidden from our direct view, lies an object of staggering gravitational power known as the Great Attractor. It is pulling not just a few stars, but entire galaxies, including our own Milky Way, toward a single point in space at a breathtaking speed of over 600 kilometers every second. Picture our local group of galaxies, a vast cosmic island, all being drawn on a journey we cannot see the end of. The most perplexing part is that we cannot see what is doing the pulling. This monstrous source of gravity lies directly behind the plane of our own galaxy, a region astronomers call the zone of avoidance. Here, thick clouds of interstellar gas and dust block almost all visible light, creating a cosmic blind spot that obscures nearly 20% of the sky. It is like trying to identify a distant mountain range from behind a permanent, impenetrable fog. For decades, this zone frustrated scientists, hiding the true nature of the force guiding our cosmic path. Through persistent effort, using telescopes that can peer through the dust with radio waves and infrared light, we have begun to map the shadows behind the curtain. What we found is not a single, incomprehensible object, but likely an immense concentration of mass. A supercluster of galaxies so dense its collective gravity creates a profound well in the fabric of space-time. This region, known as the Oumuamua cluster, is a bustling metropolis of galaxies, and it appears to be the heart of the Great Attractor. Yet, even this colossal structure may not fully account for the strength of the pull we feel. Some scientists speculate that something even larger and more exotic lies beyond it, a deeper gravitational anchor we have yet to fully comprehend. The quest to understand the Great Attractor is a humbling reminder that we are passengers on a ship sailing toward a destination we are still struggling to see, pulled by a hand hidden in the cosmic dark. Yet the hidden hand guiding our galaxy is not the only whisper from the void. On a quiet August evening in 1977, a radio telescope in Delaware, Ohio, known as the Big Ear, was silently scanning the sky. It was part of a patient, decades-long search for signs of intelligent life beyond Earth, a project often met with skepticism. Then, for exactly 72 seconds, everything changed. A powerful, narrowband radio signal burst from the direction of the constellation Sagittarius. It was not the scattered noise of a star or the broad hiss of cosmic gas. This signal was focused, intense, and it appeared on the telescope's printout with the unmistakable signature of a potential artificial broadcast. When astronomer Jerry Amon reviewed the data the next day, he was so stunned by its perfect characteristics that he circled the alphanumeric code on the paper and wrote a single, emphatic word in the margin. Wow, that single word gave the signal its immortal name. The wow signal was not like any natural radio emission scientists had catalogued before. It was incredibly strong, 30 times louder than the background noise of space. It occupied a very specific, narrow frequency, just like a finely tuned radio station, and that frequency, 1420 MHz, is a protected band. It is a quiet channel in the cosmic radio spectrum where earthly transmitters are forbidden to broadcast, a frequency that happens to be near the natural emission line of hydrogen, the most common element in the universe. Many scientists have suggested that an advanced civilization might use such a universal landmark as a logical calling card. For those 72 seconds, it seemed we might have heard one. And then it vanished. The Big Ear telescope, by its fixed design, could only listen to that specific patch of sky for 72 seconds as Earth rotation carried the source through its field of view. When astronomers pointed every instrument they could back to that exact spot, they heard nothing. No repeat, no echo, not even a faint whisper. For over 4 decades, countless searchers have scanned that region using far more sensitive equipment and have found only silence. The signal has never been heard again. This profound loneliness is what cements its mystery. If it was a deliberate broadcast, why was it only a one-time event? The search for a natural explanation has been just as frustrating. Some suggested it might have been a signal reflected off a piece of space debris, but the characteristics did not match. A passing comet was proposed, but the comets in that area were not active at the time and could not produce such a powerful, clean signal. Other ideas, like a peculiar stellar flare or an unknown form of plasma instability, have all fallen short of fully explaining the signal's unique profile. The WOW signal remains astronomy's most famous ghost. It is a single, perfect note played in a cosmic symphony, a note we have never been able to find again. It stands as a tantalizing possibility that for one brief moment in 1977, we may have brushed against something extraordinary, a beacon in the dark that flashed once and then retreated back into the eternal quiet, leaving behind only a circled code on a printout and a question that has echoed for generations. What or who said hello? That single, unanswered hello from the cosmos taught us to expect the unexpected, but sometimes the universe presents a mystery that is not a fleeting signal, but a persistent, confounding presence. In the constellation Cygnus, a star named KIC 8462852, now famously known as Tabby's star, began to whisper its own bizarre story to the Kepler Space Telescope. While Kepler was designed to find planets by spotting the gentle, regular dips in starlight caused by their orbits, Tabby's star did something completely different. Its light did not flicker, it plummeted. At irregular and unpredictable intervals, the star's brightness would drop by staggering amounts, sometimes by over 20%, as if a colossal, jagged shape were passing in front of it. These were not the clean, symmetrical curves of a planet. They were deep, chaotic trenches carved into the graph of its luminosity. One event saw the star dim by a jaw dropping 22%, a blockage that would require an object nearly half the width of the star itself. Nothing in our cosmic playbook could easily explain it. The most thrilling and wildly speculative hypothesis quickly captured the public's imagination. Could this be evidence of an alien megastructure? The idea, popularized by astronomer Jason Wright, suggested we might be witnessing the construction of a Dyson sphere, a hypothetical shell of solar collectors built by an advanced civilization to harness the entire energy output of their star. The irregular, massive blocks passing in front of Tabby's star could, in theory, be sections of this immense, incomplete swarm. For a moment, it felt like science fiction was bleeding into reality. Yet, scientists are a cautious breed, and they immediately began searching for more natural, if equally strange, explanations. The first and leading candidate was a gigantic, chaotic swarm of comets. Imagine not a few icy visitors, but a family of millions of them, perhaps disturbed from a distant cloud by the gravity of a passing star, now on a long, destructive plunge inward. As they neared the heat of their sun, they would vaporize and fracture, creating a vast, dusty debris field of irregular shapes and sizes that could cause the bizarre dimming patterns we observed. This theory had merit, but it required an almost impossibly large number of comets, a swarm of unprecedented scale. Other ideas followed. Perhaps we were witnessing the final, violent disintegration of a planet, torn apart by its star's gravity, its fragments creating a long, trailing cloud of dust and rock. Or maybe the star itself was surrounded by a thick, warped disk of interstellar dust with highly unusual properties, dust that clumped together in strange, opaque formations. Observations continued, and a crucial clue emerged from detailed studies of the dimming. The star was fading unevenly across different colors of light. It dimmed more in blue light than in red light. This is a classic signature of dust because tiny dust particles scatter blue light more effectively, just like our own atmosphere makes the sky appear blue. A solid megastructure made of metal or rock would block all colors of light equally. The dust discovery seemed to rule out the clean, geometric lines of an alien construction project. But in doing so, it only deepened the natural mystery. What kind of dust behaves like this? Why is there so much of it in such strange, clumpy formations? And why does the star's long-term brightness also show a mysterious, century-long slow fading that no one can fully explain? Tabby's star remains an unparalleled cosmic oddity, a reminder that nature, in its infinite creativity, can craft phenomena so bizarre they momentarily trick us into seeing the signature of intelligence. The truth is likely stranger than any single fiction we could invent, a puzzle written in dust and shadow around a distant sun. The eerie silence following a potential cosmic hello and the chaotic shadows around a distant star are mysteries of omission and obstruction. But sometimes the universe does not hide its strangeness. It shouts it in a language of pure, violent energy. If you could see the sky not in visible light, but in high-energy gamma rays, you would witness a structure of breathtaking scale and power emanating from the very heart of our own galaxy. Stretching 25,000 light-years above and below the galactic plane, like two colossal, symmetrical orbs, are the Fermi Bubbles, discovered in 2010 by scientists analyzing data from the Fermi Gamma Ray Space Telescope. These bubbles are a pair of the largest and most energetic features ever seen in the Milky Way. To grasp their size, consider that our entire solar system is a tiny speck orbiting about 26,000 light-years from the galactic center. One of these bubbles alone is nearly that entire distance tall. They form a vast hourglass shape with its pinched waist centered on the supermassive black hole known as Sagittarius, a star. Their edges are remarkably sharp, glowing with a haze of gamma rays, the most energetic form of light in the universe, produced by particles moving at nearly the speed of light. Their sheer symmetry and power point to a single, catastrophic event in our galaxy's past, a titanic explosion that punched these cavities through the thin gas of the galactic halo. But what was the trigger? The prime suspect sits at the very center of the structure. Sagittarius, a star, our galaxy's central black hole with a mass 4 million times that of our Sun, is currently quiet. But it may not have always been so. One leading theory suggests that several million years ago, it experienced a monstrous feeding frenzy. As a vast cloud of gas or even a star was torn apart and consumed, the black hole's accretion disk would have become a furious maelstrom, channeling some of the infalling material into two opposing jets of plasma shot out from its poles at relativistic speeds. These jets, blasting through space for perhaps 100,000 years, could have inflated these giant bubbles, their shockwaves accelerating particles to energies that still produce gamma rays today. It would have been a brief, violent scream in the life of the galaxy. Another compelling theory looks not to the black hole, but to a frenzy of stellar birth and death. In the dense, chaotic region around the galactic center, there could have been a period of intense star formation, a so-called starburst. This would have created countless massive stars that live fast and die young in spectacular supernova explosions. The combined energy of hundreds or thousands of these explosions, happening in a relatively short cosmic time frame, could have blown a giant collective wind that carved out the bubbles. Both explanations are plausible, yet both leave puzzles. The black hole jet theory must explain the incredible symmetry and smooth edges of the bubbles, which suggest a relatively clean, focused eruption. The starburst theory must account for the sheer, concentrated energy required to create structures of this scale. The Fermi Bubbles stand as a ghostly monument to a cataclysm we missed, a reminder that even our seemingly placid galactic home has a violent and energetic history written across the sky in invisible, high-energy light. This monument to a forgotten cataclysm shows a universe of immense structures, but not all cosmic architecture is built from light and energy. Some are defined by a profound and unsettling absence. In the constellation of Boötes, the herdsman, lies a region of space so empty it has earned the name the Great Nothing. The Boötes Void is a spherical chasm approximately 330 million light-years across. To comprehend that scale, if you placed our Milky Way galaxy at its center, the nearest edge of this void would still be over 165 million light-years away in every direction. In a universe woven together by the cosmic web, a vast filamentary structure where galaxies cluster along glowing strands like dew on a spider's web, the Boötes Void is a gaping hole. While a typical region of space that size should contain at least 10,000 galaxies, astronomers have catalogued only around 60 within this terrifying expanse. That means galaxies here are on average 500 million light-years apart. If you lived on a planet inside the void, your night sky would be nearly black, with a few neighboring island universes appearing as faint, lonely smudges. The emptiness is so vast it should not exist according to our best models of how the universe evolved after the Big Bang. Gravity acts like a cosmic sculptor, pulling matter together over billions of years. The slight irregularities in the early universe grew into the dense clusters and filaments we see today, leaving behind less dense areas we call voids. But the Boötes Void is not just a low-density region. It is a staggering abyss, an order of magnitude emptier than any typical void. How did it get so empty? One leading theory suggests it is not a single void, but a cosmic accident where several smaller voids merged together over time, like soap bubbles coalescing into one gigantic bubble. The galaxies we do see inside it might be tracing the faint, surviving filaments of that older web, now stranded in an ocean of nothing. Another, more speculative idea proposes that something in the very early universe, perhaps a phase transition or an interaction with an exotic form of energy, created a seed of such extreme low density that it expanded into this colossal desert. The void challenges astronomers because it forces us to question whether our understanding of the cosmic web is complete. Is the universe simply more lumpy and uneven on the largest scales than we thought, capable of producing such staggering deserts by chance? Or does the Great Nothing hint at processes in the infant cosmos that we have not yet imagined? It stands as a silent reminder that in the grand tapestry of creation, the most terrifying pattern might be the one that is not there at all, a blank spot in the stellar map that echoes with questions. From the terrifying emptiness of the void, we now find a structure of almost impossible perfection. Floating in the constellation Monoceros, the unicorn, is an object that looks less like a cosmic accident and more like a piece of divine geometry. Astronomers call it the Red Rectangle Nebula, a name that fails to capture its breathtaking symmetry. Through the lens of powerful telescopes, this nebula appears as a stunning, three-dimensional X-shape, its arms forming a series of nested, concentric rectangles that glow with a deep, ruby-red hue. It is a cosmic cathedral of dust and gas, a structure so orderly it seems to defy the chaotic, turbulent nature of most stellar nurseries and death shrouds. This is not the explosive aftermath of a supernova or the gentle glow of a star-forming cloud. This is something else entirely, a celestial artifact carved with a precision that feels almost intentional. At the heart of this geometric wonder lies a binary star system known as HD 44179. One of these stars is a dying, aging sun that has puffed off its outer layers, creating a vast cloud of gas and dust. But instead of expanding in a messy, spherical shell, this material is being shaped with extraordinary control. The key is the dance of the two stars. As they orbit each other, they channel the expelled gas into two powerful, opposing jets that shoot out from their poles. Imagine a spinning top that sprays twin streams of water in perfect, steady cones. Now surround that entire system with a thick, dense donut of dust called a torus that wraps tightly around the star's equator. This torus acts like a corset, squeezing the outward flow of gas and forcing it to escape only through the openings at the top and bottom, intensifying those polar jets. As the jets plow into the slower-moving gas ejected earlier, they create shock waves that make the material glow, tracing the edges of the geometric form we see. The nested rectangles likely come from pauses or pulses in the ejection process, like rings in a tree trunk marking periods of growth. Yet, for all we understand about the ingredients, the recipe remains a mystery. The process should, in theory, create a messy hourglass shape which we see in many other nebulae. But the red rectangle's edges are shockingly sharp, its corners crisp, its symmetry flawless across vast distances. What physical process keeps these structures so perfectly aligned over thousands of years? Why does the dust behave in such a coordinated way? It is as if nature, for a moment, decided to trade its usual abstract expressionism for the precise lines of a technical drawing. The red rectangle stands as a beautiful enigma, a reminder that even in the cold equations of astrophysics, there is room for art, a masterpiece painted in hydrogen and dust whose final brushstroke we do not yet understand. But geometry is not the only language of mystery. Sometimes a story begins not with a telescope's image, but with a persistent human whisper. For decades, a legend has circulated among conspiracy circles about a silent sentinel from another world, an object called the Black Knight satellite. The tale claims that for over 13,000 years, an alien probe of unknown origin has been orbiting our planet, watching us, its dark, non-reflective surface hiding it from casual observation. The evidence cited is a collection of eerie breadcrumbs. In the late 1890s, Nikola Tesla reported picking up strange, rhythmic radio signals during his experiments with high-voltage coils in Colorado Springs. He speculated they might be of extraterrestrial origin, perhaps from Mars. Decades later, in 1960, a Time magazine article mentioned that the United States Navy had detected a mysterious dark object in a polar orbit, something they could not immediately identify. These fragments, woven together over years, created a compelling myth of an ancient watcher in the sky. The legend grew with grainy photographs from early space missions that seemed to show a strange, angular object against the curve of the Earth, and with claims of radio signals repeating in a mathematical pattern that hinted at intelligence. It is a story that taps directly into our deepest fascination with the idea that we are not alone, and that evidence of that fact has been hiding in plain sight just overhead. The reality, as is often the case, is far more mundane yet no less fascinating. Space is cluttered with debris, and the history of human spaceflight is a history of leaving things behind. The most plausible explanation for the infamous grainy photographs, like one from the 1998 STS-88 Space Shuttle mission, is not an alien artifact but a lost piece of our own technology. Analysts identified the object as a thermal blanket that had drifted away during a spacewalk, its angular appearance caused by the way it tumbled and caught the light. As for the mysterious object tracked by the Navy in 1960, it was almost certainly the remains of a Discoverer satellite, a secret military reconnaissance program whose launches and payloads were not publicly acknowledged at the time. The Discoverer series used a polar orbit exactly as described, and the discarded upper stages or shrouds from these rockets would appear as unidentified dark objects to tracking stations. Even Tesla's signals have a likely natural explanation. We now know the universe is filled with natural radio pulsars and the plasma phenomena of Earth's own ionosphere, which could produce the repetitive signals he detected. The Black Knight satellite, then, is a powerful lesson in how mystery is born. It is the human mind connecting dots across history, taking real anomalies of tracking and perception and weaving them into a narrative that feels profound. The truth removes the alien architect, but it leaves us with a different, poignant reality. Our own planet is now encircled by a shell of our own making, a cemetery of forgotten missions and discarded tools, each piece a testament to our ambition to reach beyond our world. The real Black Knights are the ghosts of our own early steps into the cosmos, silent monuments to a different kind of history entirely. Our own orbital debris tells a human story, but some structures in the void defy any story we know how to tell. Scattered across the deep radio sky, astronomers have found something that simply should not be there. They are called odd radio circles, or ORCs, and their name is a perfect understatement. Discovered only a few years ago by Australia's ASCAP radio telescope array, these are enormous, faint rings of radio emission hanging in space. They are not visible in optical light, infrared, or X-rays. To our eyes and to most of our instruments, the regions they occupy appear as empty, black nothing. But switch the view to the radio spectrum, and these ghostly halos emerge, perfect circles glowing with the energy of synchrotron radiation, which is given off by electrons spiraling at nearly light speed around magnetic fields. Their scale is almost incomprehensible. A single ORC is so vast it could easily swallow our entire Milky Way galaxy whole with room to spare. They are not small objects in the foreground. They are colossal structures millions of light years across, meaning they are among the largest single entities ever identified in the universe. And what makes them truly odd is that we have absolutely no idea what they are. The leading theories all sound like they are pulled from the pages of speculative fiction. One idea is that they are the titanic shockwaves from a cataclysmic event at the center of a galaxy, perhaps a merger of two supermassive black holes. Such an event could send a spherical tsunami of energy blasting out through intergalactic space for eons, and we might be seeing the circular edge of that wave as it interacts with thin intergalactic plasma. Another thought is that they could be the throats of wormholes, theoretical tunnels through space-time, though this remains a highly speculative and exotic possibility with little direct evidence. Some have even proposed they are the immense, glowing remnants of a starburst so powerful it blew a galaxy's gas clean away in a perfect sphere, yet none of these explanations fit perfectly. If they are shock waves, what caused the central explosion to be so perfectly symmetrical and so incredibly energetic? If they are related to galaxies, why do some ORCs appear to have a galaxy at their center while others do not? Their perfect circularity is itself a profound puzzle, as most cosmic explosions and outflows are messy, distorted things. The ORCs represent a brand new class of cosmic mystery, one we literally did not have a name for until very recently. They remind us that the universe is still writing its rulebook, and every time we build a new kind of eye to see the cosmos, it shows us wonders we never dreamed of asking about. The ghostly halos of odd radio circles show us that the cosmos still holds forms we cannot name, but sometimes the mystery arrives not from the distant depths but from our own celestial doorstep. In October 2017, a telescope in Hawaii scanning for near-Earth asteroids caught a faint, fast-moving streak of light. It was given the name Oumuamua, a Hawaiian word meaning scout or messenger from the distant past. Calculations of its path sent a jolt through the astronomical community. This was no ordinary comet or asteroid from our own solar system. Its trajectory was hyperbolic, meaning it was moving far too fast to be bound by the sun's gravity. Oumuamua was our first confirmed visitor from another star system, a cosmic tourist passing through. As telescopes around the world swiveled to observe it, the strangeness only deepened. The object exhibited no visible coma, the fuzzy cloud of gas and dust that surrounds active comets. It appeared as a bare, dark rock tumbling through space. But the most baffling data came from its brightness. As it rotated, its reflected light varied in intensity by a factor of 10, an extreme difference that implied a shape unlike anything we commonly see. Oumuamua was not spherical or lumpy. The best fit for the data suggested it was profoundly elongated, perhaps 10 times as long as it was wide, a shape likened to a cosmic cigar or a flat pancake. Then came the real curveball. Precise tracking revealed that Oumuamua was not following a purely gravitational path around the Sun. It was accelerating ever so slightly on its way back out of the solar system. This non-gravitational acceleration is something comets do, as the Sun heats their icy surfaces and they vent gas in jets, acting like a natural rocket engine. But Oumuamua showed no signs of such outgassing. No dust tail, no gas cloud, no chemical signatures in its spectrum. It was accelerating in silence. This paradox ignited a fierce and public scientific debate. One camp, led by Harvard astrophysicist Avi Loeb, proposed a breathtaking possibility. Could the acceleration be explained by radiation pressure from the Sun? For that to work, Oumuamua would need to be extremely thin and light. Loeb famously suggested it might resemble a light sail, a piece of technology designed to be pushed by starlight, perhaps a derelict artifact from an advanced civilization. While captivating, this hypothesis was met with intense skepticism from much of the scientific community. Others raced to find natural explanations. Perhaps it was a fractal-like dust aggregate, a loose snowflake-like structure so light that even the faint pressure of sunlight could push it. Or, as later research proposed, maybe it was a comet after all, but one made of something we rarely see, molecular hydrogen ice. A chunk of solid hydrogen warmed by the Sun would sublimate directly into an invisible gas, providing the thrust without leaving a visible trail. Yet hydrogen ice is so fragile it should not survive a long journey between stars. Every explanation seemed to require something unusual, pushing the boundaries of known physics or chemistry. Oumuamua refused to fit into a neat box. It was not a typical comet nor a standard asteroid. It was a category of one, a messenger that delivered a single, profound lesson before vanishing into the interstellar dark. Its greatest legacy was to rip open a new field of astronomy. We now know interstellar objects are not fantastically rare, and new projects are actively scanning the skies for the next visitor. Oumuamua taught us to expect the unexpected right in our own backyard, and proved that sometimes the most world-changing discoveries are the ones that slip quietly past, leaving only a trail of brilliant questions in their wake. Oumuamua's silent acceleration hinted at forces we could not see, but what if the entire cosmos was experiencing a similar, unseen pull? This brings us to one of the most profound and controversial mysteries in modern cosmology, known as the dark flow. Imagine mapping the motion of thousands of massive galaxy clusters, each one a metropolis of 1,000 galaxies, all drifting through the expanding universe. According to our fundamental understanding, this motion should be random, a gentle and chaotic drift within the cosmic expansion. Yet, when scientists analyzed data from the Wilkinson Microwave Anisotropy Probe, a satellite that studied the afterglow of the Big Bang known as the cosmic microwave background, they found something that defied expectation. These colossal clusters appeared to be streaming in a coherent direction, a vast, silent river of matter moving at speeds exceeding 2 million miles per hour toward a single point in the sky near the constellations Centaurus and Vela. It was as if something immense, lying far beyond everything we can observe, was exerting a gravitational tug on the very fabric of our universe. The scale of this suggestion is difficult to overstate. The observable universe is a sphere about 93 billion light-years across, containing all the matter and energy we could possibly see since the Big Bang. The dark flow implies that the source of this pull lies outside of that sphere, in a region of space-time from which no light has had time to reach us. This leads to staggering possibilities. One is that our universe is not alone, and the gravitational influence of another, separate universe is bleeding into our own, a ghostly hand from a cosmos beyond our own. Another, even more mind-bending idea is that the structure causing this flow is a relic from before the Big Bang itself, a scar or imprint from an earlier epoch of reality that still guides the motion of matter today. Unsurprisingly, such radical claims have met with intense skepticism. Critics argue the signal could be an artifact of the complex data analysis or incomplete understanding of how galaxy clusters interact with the cosmic microwave background. Subsequent studies have produced conflicting results, with some supporting the original finding and others finding no evidence of a coherent flow. The controversy highlights a beautiful tension in science, where an extraordinary claim demands not just evidence but overwhelming, repeatable proof. The search for that proof continues, with newer telescopes and more precise measurements scrutinizing the heavens. The dark flow, whether ultimately confirmed or dismissed, forces us to confront the ultimate horizon of our knowledge. It asks if the universe we see is merely our island in a far greater and stranger cosmic archipelago. If the dark flow hints at unseen forces beyond our cosmic horizon, other mysteries are frozen in time within it. In the constellation Perseus, a relic from the dawn of creation drifts in silent defiance. The galaxy NGC 1277 is not like the vibrant spirals or bustling ellipticals we see today. It is a cosmic fossil, a snapshot of the universe frozen roughly 10 billion years ago. While most galaxies have continued to churn through cycles of star birth and death, this one appears to have simply stopped. Its stellar population is eerily uniform, composed almost entirely of ancient, aging red stars. The brilliant blue light of hot, young stars, the hallmark of ongoing stellar nurseries, is conspicuously absent. It is a galaxy that went into stasis when the universe was just a fraction of its current age, and it has stubbornly refused to evolve since. This presents a profound puzzle for astronomers. Our standard models of galactic evolution are stories of dynamic change. Galaxies grow by merging with others, their collisions triggering bursts of new star formation and feeding their central black holes. They consume gas from the intergalactic medium to fuel future generations of stars. Yet NGC 1277, a massive galaxy in its own right, seems to have bypassed all of this activity for eons. How does a galaxy simply turn off? One compelling theory is that it experienced a ferocious initial burst of star formation that used up all its available cold gas in a cosmic frenzy, leaving nothing left to make new stars. Then, perhaps due to its location or motion within its galaxy cluster, it was cut off from fresh inflows of intergalactic fuel. It became an island stranded in time, its stellar population aging in unison. But the strangeness does not end with its stars. At the heart of this fossil galaxy lies a gravitational monster of almost impossible proportions. Its supermassive black hole is a behemoth comprising a staggering 14% of the galaxy's entire bulge mass. To put that in perspective, the supermassive black hole at the center of our Milky Way makes up only about 0.1% of our galactic bulge's mass. This is like comparing a pebble to a boulder. In NGC 1277, the black hole is not just a resident, it is the overwhelming landlord. This discovery appends another established rule, which suggested that the mass of a central black hole grows in lockstep with the galaxy around it. Here, the black hole is vastly overgrown, suggesting it formed or was seeded very early in the universe's history, perhaps before the galaxy itself finished assembling. This ancient galaxy, with its frozen stars and monstrous heart, serves as a unique time capsule. It allows us to peer directly into the early universe and see the kinds of systems that were common in that violent, formative era. Its existence tells us that the pathways of cosmic evolution are more varied and mysterious than our tidy models once suggested. Some galaxies race forward while others, like this celestial sleeping beauty, simply stop, preserving the secrets of the cosmos's youth in their silent red glow. While some galaxies preserve the ancient past, other worlds forge themselves into something utterly alien in the present. orbiting a sun-like star 40 light-years away in the constellation Cancer, is a planet that seems ripped from the pages of a cosmic fantasy. Known as 55 Cancri, this world is a super-Earth, a type of planet with a mass several times greater than our own, but the similarity ends there. Based on its density and the chemistry of its host star, astronomers believe this world is not made of rock and iron like Earth, but is overwhelmingly composed of carbon. Under the unimaginable pressures deep within its interior, that carbon is likely compressed into a crystalline structure. This is not a world with diamond mines. This is, in all probability, a planet-sized diamond, a glittering jewel of staggering scale adrift in the void. The conditions on its surface are the stuff of nightmares. It orbits so close to its star that a full year, one complete trip around, takes only about 18 hours. This blistering proximity bakes the planet. Daytime temperatures are estimated to soar above 4,000 degrees Fahrenheit, hot enough to melt granite and vaporize most metals. The surface is likely a global ocean of molten lava, a seething, incandescent sea under a black, star-choked sky. Some models even suggest the planet is tidally locked, with one hemisphere permanently facing the star in a perpetual, scorching day, and the other plunged into an eternal, slightly cooler night. The atmosphere, if it exists at all, would be a thin, toxic shroud of vaporized rock and carbon compounds. The discovery of 55 Cancri shattered our preconceptions of what a planet could be. Our solar system, with its rocky inner planets and gaseous outer giants, is built from material rich in oxygen and silicon. But around other stars where the protoplanetary disk had a different chemical mix, planets can form from entirely different recipes. A carbon-rich disk would spawn worlds like this one, where graphite and diamond take the place of granite and basalt. This opens a universe of exotic possibilities. Could there be planets made of solid graphite, or worlds with mountains of pure carbon? The existence of this diamond planet forces us to expand the catalogue of planetary geology to include realms of almost alchemical strangeness. It is a stark reminder that the universe is not merely a factory for producing copies of our own neighborhood, but a limitless workshop capable of crafting wonders beyond our wildest imagination, where a world of eternal fire can also be a gem of breathtaking cosmic value. A diamond world forged in stellar fire represents one extreme of cosmic chemistry, but another discovery reveals the opposite, a substance so simple and pure it defies the modern galaxy. Drifting toward the spiral arm of our Milky Way is an ethereal spectre known as HVC 127-41-330. This is not a star, nor a planet, nor even a dust cloud. It is a colossal, diffuse cloud of neutral hydrogen gas, a ghostly ribbon of primordial matter hundreds of light-years across, moving at a blistering speed that will soon send it crashing through the galactic disk. Its true strangeness, however, lies not in its velocity but in its breathtaking purity. When astronomers analyzed its spectral signature, they found it contains almost none of the heavy elements astronomers call metals. In the language of astrophysics, metals are any element heavier than hydrogen and helium. This cloud, by contrast, is 99.99% pure hydrogen and helium. It is a pristine relic, a fossilized bubble of gas that has remained untouched and unchanged for over 13 billion years, since the universe's first few minutes. Every other structure we see in the cosmos, stars, planets, nebulae, even our own bodies, is enriched with these heavier elements. They were forged in the nuclear furnaces of stars and scattered across space by supernova explosions, seeding future generations of solar systems. This cloud, however, never participated in that cycle. It is a cosmic hermit, a wandering shard of the primordial soup that somehow avoided being swept up into a galaxy, never feeling the gravitational collapse that ignites a star. It is a living piece of the universe's raw construction material, a fossil not locked in stone but drifting in the void. By studying its exact composition, scientists gain a direct window into the conditions immediately after the Big Bang. They can measure the ratios of hydrogen isotopes with exquisite precision, testing our models of nucleosynthesis, that fleeting moment when the basic ingredients of everything were cooked into existence. The cloud's impending collision with our galaxy is a slow-motion experiment of profound importance. As it plows into the denser gas of the Milky Way's disk, the shock will likely trigger the very process it avoided for eons, the birth of new stars. But these stars will be unlike any others in our neighborhood. They will be population 3 stars formed from almost pure hydrogen and helium, and they will burn hotter, brighter, and die more violently than any star we have ever seen. This galactic ghost is a messenger from a time before light, a silent witness to the dawn of everything, now arriving at our doorstep to deliver its ancient secrets. A stellar explosion is supposed to be a final, definitive end. Yet deep within the constellation Ursa Major, astronomers witnessed a star that refused to die. Supernova 2012Z was a brilliant event, but as the light faded, something impossible remained. The white dwarf star that had exploded was still there, a smoldering, wounded remnant of its former self. This bizarre phenomenon belongs to a rare class known as Type IX supernova, events so strange they have earned the nickname zombie star explosions. In a typical Type Ia supernova, a white dwarf, the dense, Earth-sized corpse of a Sun-like star, steals so much material from a companion star that it crosses a critical mass threshold. This triggers a runaway thermonuclear explosion so complete and violent that it utterly obliterates the white dwarf, leaving nothing behind but an expanding cloud of glowing debris. The zombie star scenario is different. Here, the thermonuclear flame does not consume the entire star. Instead, it races through the white dwarf in a partial, incomplete detonation. It is like a firecracker that only partially ignites, blowing off the outer layers violently but leaving the core cracked and damaged, yet fundamentally intact. The explosion kicks this zombie remnant, this stellar survivor, away from the blast site at incredible speed, while the companion star, itself battered and stripped, is sent careening off in the opposite direction. What we are left with is not cosmic dust, but a bizarre, reanimated corpse of a star, still shining with residual heat from the failed blast, now wandering the galaxy alone. This discovery fundamentally challenges the textbook model of stellar death. For decades, Type Ia supernova were considered standard candles, predictable explosions used to measure cosmic distances because their peak brightness was thought to be uniform. The existence of these partial explosions reveals a far messier and more varied reality. Why does the flame sometimes fail to consume the whole star? The leading theory points to the ignition process itself. Perhaps in these cases, the nuclear flame ignites not at the very center of the white dwarf, but off-center, or maybe it burns as a deflagration wave, a subsonic simmer, rather than a supersonic detonation shockwave. This slower burn might eject the outer layers before the flame can reach and consume the dense core. Studying these zombie remnants provides a unique laboratory for astrophysicists. They offer a chance to peer inside the guts of a supernova in progress, to understand the precise mechanics of how a nuclear flame propagates through degenerate matter. By analyzing the light from these events and the composition of the ejected material, scientists can test models of nucleosynthesis in incomplete explosions, seeing which heavy elements like iron, silicon, and nickel are forged and in what amounts. Each zombie star is a cosmic autopsy report detailing a death that wasn't quite final, a stellar phoenix that rose from its own ashes only to live on as a ghost of its former self. A galaxy without dark matter should be an impossibility. It is the cosmic scaffolding, the unseen glue that holds the spinning disks of galaxies together, preventing them from flying apart. Yet in the constellation Cetus, a ghostly smudge of light named NGC 1052DF2 does exactly that. This is an ultra-diffuse galaxy, a wispy, almost transparent collection of stars so thinly spread you can see right through it to the galaxies beyond. Its stars are old and red, and it possesses almost no gas to form new ones, but its true strangeness was revealed not by what we see but by what we do not feel. Astronomers turned their telescopes to the galaxy's bright globular clusters, the dense balls of ancient stars that orbit its core. By measuring the speed of these clusters, they could calculate the total mass of the galaxy pulling on them. The faster they move, the more mass must be present to hold them in orbit. The results were shocking. The clusters were moving slowly, lazily, as if there was almost nothing holding them there. When the scientists subtracted the visible mass of the stars, they found the remainder, the presumed dark matter, was essentially zero. This galaxy, by all accounts, is made of stars and nothing else. The discovery sent a tremor through cosmology. For decades, dark matter has been the cornerstone of our understanding of how the universe is structured. We believe it forms vast, invisible halos that cradle galaxies, providing the gravitational seed for normal matter to clump together in the first place. A galaxy without it is like a building without a foundation, a structure that according to our blueprints should not exist. So what happened here? One compelling theory is one of cosmic violence. Perhaps NGC 1052DF2 was once a normal dwarf galaxy with a full dark matter halo, but it had a catastrophic encounter. It might have plunged through the dense center of a much larger galaxy, where immense gravitational tides could have ripped away not only its gas and outer stars, but also stripped its dark matter, leaving behind this ethereal stellar skeleton. Another, more radical idea is that this galaxy formed in a completely different way, perhaps from gas thrown out during a chaotic galactic collision, material that coalesced into stars without a dark matter anchor at all. The debate this object ignited is fierce and fundamental. Its very existence challenges the universality of dark matter. Could our models be wrong, or does this galaxy represent a rare exception that proves the rule, a cosmic accident that teaches us about the messy, violent interactions that can reshape galaxies? The search is now on for other dark matter-deficient galaxies to see if this is a fluke or a new class of object. NGC 1052DF2 stands as a profound question mark in the sky, a ghostly reminder that even our most fundamental cosmic rules are written in pencil, not stone, and are always waiting for the next impossible discovery to come along and rewrite them. The absence of dark matter in a galaxy challenges our cosmic foundations, but another ghostly imprint in the oldest light we can see suggests a flaw in the very blueprint of reality itself. Embedded in the map of the cosmic microwave background, the faint afterglow of the Big Bang, is a chilling anomaly known simply as the cold spot. This region of space, spanning over 1 billion light-years, is significantly colder than the surrounding background by about 70 microkelvins. While that temperature difference sounds minuscule, its sheer scale makes it a statistical nightmare. According to our best models of the universe's origin and evolution, a feature this large and this cold should not exist. The odds of it appearing by random chance in a standard model cosmos are less than 1 in 200. It is a cosmic bruise on the infant universe, and its origin is one of the most heated debates in cosmology. One dramatic and mind-bending explanation ventures into the territory of science fiction. Some theorists propose that the cold spot is not a feature of our universe at all, but a scar from a collision with another universe in the multiverse. The idea is that if our universe is just one bubble in a frothing sea of other bubble universes, these bubbles could, on rare occasions, gently bump into one another. Such a collision in the early cosmos could have drained energy from that region of space, leaving behind a permanent cold patch in the CMB, a cosmic fingerprint from a reality beyond our own. It is a breathtaking possibility that turns the cold spot into a window to another cosmos, A more conventional, though no less strange, theory looks for the cause within our own universe. This explanation posits that the cold spot is not a primordial flaw, but a secondary effect caused by a titanic emptiness lying between us and the CMB. They call it the Eridanus supervoid. The concept relies on an effect known as the integrated Sachs-Wolf effect. As light from the CMB travels across billions of light years to reach us, it passes through the evolving gravitational landscape of the universe. If it passes through a vast underdense region, a supervoid, on its journey, the light must climb out of a gravitational well that is actually becoming shallower as the universe expands. This unusual process costs the light energy, shifting it to longer, cooler wavelengths and making that region of the CMB appear colder. It is a cosmic mirage of staggering scale. The problem is, the void required to produce such an effect would need to be unimaginably vast and profoundly empty, even larger than the cold spot itself. While some surveys have indeed found a large underdense region in the general direction of the cold spot, its size and emptiness do not seem sufficient to explain the full magnitude of the temperature drop. The void is big, but perhaps not big enough. This leaves cosmologists at an impasse. The multiverse collision idea is compelling but currently untestable, residing in the realm of theoretical speculation. The supervoid explanation is more grounded, but the observed data does not perfectly match the prediction, suggesting either our measurements are incomplete or our understanding of how light interacts with such immense structures is flawed. The cold spot remains a stubborn, cold splotch on our most sacred map of creation. It whispers that either our universe is far stranger than we dreamed, capable of interacting with unseen siblings, or that the empty spaces within it hold mysteries of gravity and expansion we have yet to fully comprehend. Either answer leads us to a deeper, colder frontier. That stubborn cold spot challenges the very birth of our universe, but another ancient object once threatened to break cosmology entirely. It is called the Methuselah star, officially catalogued as HD 140283, a faint, unassuming point of light in the constellation Libra. For years, astronomers have studied this nearby star, and initial measurements of its age delivered a result so shocking it seemed to unravel reality. Based on its brightness, temperature, and most crucially, its chemical composition, models suggested this star was a staggering 16 billion years old. There was just one catastrophic problem. The best estimate for the age of the universe itself, derived from the expansion rate and the cosmic microwave background, was only 13.8 billion years. A star cannot be older than the cosmos that contains it. This was not a minor discrepancy. It was a fundamental paradox that, if true, meant one of the pillars of modern science was completely wrong. The tension forced scientists to scrutinize every single variable with ruthless precision. They re-examined the star's distance, a critical factor for determining its intrinsic brightness and thus its age. New data from the Gaia satellite provided a more precise parallax measurement, slightly adjusting the star's distance and therefore its calculated luminosity. They dove deeper into the complex physics of stellar interiors, particularly the precise rates of nuclear fusion and the opacity of the stellar material. They realized that the models for these ancient, metal-poor stars needed refinement, especially regarding the amount of oxygen they contained, which affects how energy is transported within the star. With each painstaking adjustment, the calculated age of the Methuselah star crept downward. The current best estimate now places it at around 14.5 billion years, give or take 800 million. This age, while still extraordinarily ancient, finally fits within the margin of error of the universe's age. The crisis was averted, but the lesson was profound. The Methuselah star did not break cosmology. It stress-tested it, pushing our models and measurements to their absolute limit and forcing us to improve them. The true wonder of this star is not in a resolved paradox, but in what it genuinely is. Its composition is the key. It contains only a tiny fraction of the heavy elements, the metals, that are abundant in our Sun and in our own bodies. This makes it a population 2 star, a member of the second generation ever to ignite in the cosmos. It formed from gas that had been seeded with just a sprinkling of elements forged in the very first, short-lived supernova of the universe's initial generation of massive stars. Gazing at the light from HD 140283 is quite literally looking back in time. Its photons carry the signature of a cosmos only a few 100 million years old, a time when the first galactic structures were just beginning to coalesce from the primordial dark. This star is a living fossil, a witness to the dawn of light itself, and its survival for over 95% of cosmic history is a humbling reminder of the vast, slow rhythms of deep time. A stellar fossil from the dawn of time shows the universe's slow rhythm, but sometimes the cosmos moves with unimaginable violence. Astronomers have spotted a monster on the run. Streaking through the void at over 4 million miles per hour is a supermassive black hole, an object with a mass equivalent to 20 million suns, and it is fleeing its home galaxy. What they captured in Hubble Space Telescope images is not the black hole itself, for no light can escape it, but its devastating wake, stretching for an astonishing 200,000 light-years, twice the diameter of our Milky Way, is a brilliant contrail of newborn stars. This is the signature of a gravitational titan tearing through space, a runaway behemoth leaving a scar of creation in its path. The scene is one of terrifying beauty. As the black hole plows through the thin gas that permeates intergalactic space, it does not simply swallow everything. Instead, its immense gravity compresses the gas in front of it, like the bow wave of a cosmic ship. This compression triggers shock waves that heat the gas and then cause it to collapse under its own weight, igniting the fires of nuclear fusion. The result is a narrow, almost linear corridor of young, blue stars, a stellar jet trail marking the black hole's frantic escape. It is a cosmic event of biblical proportions where an agent of destruction becomes inadvertently an architect of light. How does a gravitational anchor, an object so massive it should sit unmoving at the very heart of a galaxy, get hurled into the deep void? The answer lies in a gravitational drama of almost perfect chaos. The most likely scenario involves not 2, but 3 supermassive black holes. When galaxies merge, their central black holes eventually sink to the new core and begin a slow orbital dance. If a third galaxy joins the fray, bringing its own black hole, the system becomes unstable. In a chaotic gravitational tango, one of the black holes can be slingshotted outward at tremendous speed, like a stone from a celestial catapult. This is precisely what scientists believe happened here. The runaway black hole was likely the loser in a 3-body interaction, ejected from the galactic core while the other 2 black holes continued to spiral together, eventually merging in a titanic burst of gravitational waves. The discovery forces us to rewrite the story of how galaxies evolve. We once pictured supermassive black holes as sedentary kings, ruling from their thrones at the centers of galaxies. Now we must consider that they can be vagabonds, exiled monarchs wandering the cosmic highways. This also solves a long-standing puzzle. How do we find supermassive black holes in seemingly empty space, far from any visible galaxy? Some may have been born in small, devoured dwarf galaxies, but others, like this runaway, are galactic ejectees. Its trail of stars is more than just a ghostly footprint. It is a unique laboratory, a tube of pristine star formation untouched by the turbulent environment of a galactic disk. By studying the stars in this wake, astronomers can learn about the conditions of the raw intergalactic medium and the precise physics of how black holes can trigger, rather than just destroy, the birth of suns. This runaway giant shows us that even the most powerful forces in the universe are not immune to being cast out, sent careening through the dark, painting a line of new light across the canvas of nothing. This runaway giant proves black holes can be exiles, but the darkest of neighbors might be hiding in plain sight, so close we almost missed it. In the constellation of Monoceros, the unicorn, astronomers have found a celestial beast of a different kind. This unicorn is not a mythical creature, but the closest known black hole to Earth, a silent phantom lurking a mere 1,500 light-years away. Its discovery was a masterpiece of indirect detection, a story written not in light, but in a subtle gravitational dance. Scientists were studying a familiar red giant star, a swollen, aging sun, when they noticed something peculiar. The star was wobbling, as if an invisible partner were tugging on it in a slow, rhythmic orbit. By meticulously mapping the star's subtle back and forth motion, they could calculate the mass of its unseen companion. The result was startling. The invisible object possessed about 3 times the mass of our own sun, all compressed into a volume of darkness that emitted no light whatsoever. It could only be a black hole. This finding, however, placed the unicorn in a mysterious cosmic borderland known as the mass gap. For years, astronomers have observed a curious void in their catalogues. Neutron stars, the ultra-dense cores left after a supernova, top out at around 2.2 solar masses. Black holes, formed from the collapse of the most massive stars, seem to start at around 5 solar masses. Between 2.2 and 5 solar masses, there was a puzzling desert, a gap where almost no compact objects were found. The unicorn, at 3 solar masses, sits squarely in this enigmatic zone. Its existence challenges our understanding of stellar death. Did a star collapse directly into this low-mass black hole under unusual conditions? Or could it be the product of a neutron star that grew too heavy, perhaps by cannibalizing a companion, and then collapsed into a black hole? The unicorn is a crucial clue that this mass gap might not be empty, but simply populated by dark, quiet objects we have lacked the tools to see. And that is its second profound revelation. This black hole is utterly quiet. It is not actively feeding, not ripping material from its companion star to create a blazing, telltale accretion disk. It is a dormant monster, a sleeping shadow. If such a nearby black hole could remain hidden for so long, simply by being inactive, how many more are drifting silently through our galactic neighborhood? The discovery of the unicorn suggests our census of black holes is vastly incomplete. We have been counting the loud, violent ones, the ones shining in X-rays as they feast. But for every shrieking black hole, there may be dozens, even hundreds of these silent ghosts orbiting unseen around ordinary stars. Finding the closest one has opened our eyes to a hidden population, a dark tapestry woven between the stars, reminding us that sometimes the most profound discoveries are not made by looking for light, but by listening for the quietest gravitational whispers in the night. A silent black hole is a master of hiding, but some galactic collisions announce themselves with a spectacle of light. In the constellation Boötes, a galaxy named R5519 spins in a form of impossible perfection. It is a cosmic bullseye, a vast, luminous ring of brilliant blue stars with a dark, empty hole at its center. This is not a spiral galaxy seen edge-on, nor a trick of perspective. It is a collisional ring galaxy, one of the rarest and most violent works of art in the universe, a structure born from a single, catastrophic event. The story of its creation reads like a cosmic sniper shot. Billions of years ago, a smaller, compact galaxy was on a collision course with a larger, flat disk galaxy similar to our Milky Way. But this was no messy, head-on crash. The smaller galaxy did not strike the disk's edge. Instead, in a freakishly precise accident, it punched directly through the very center of the larger galaxy's disk, like a bullet piercing the heart of a spinning vinyl record. The gravitational shockwave from this central impact radiated outward through the disk at incredible speed. This wave did not destroy the galaxy, it sculpted it. The shock compressed the vast reservoirs of gas and dust that were spread evenly throughout the disk. forcing this material into a single, expanding ring of incredible density. As this ring of matter rushed outward, the immense pressure within it triggered a firestorm of star formation. The entire structure lit up with the birth of millions of hot, young, blue stars, tracing a perfect circle of light against the void. Meanwhile, the galactic core, now stripped of most of its gas by the passing intruder, was left as a quiet, aging hub in the middle of a growing emptiness. The result is a galaxy that looks like a celestial donut, a loop of stellar fireworks surrounding a dark central gap. The rarity of such an object cannot be overstated. For a ring this clean and symmetrical to form, the angle, speed, and size ratio of the collision must be exquisitely precise. A slightly off-center impact creates a lopsided, messy wreck. A direct hit with a galaxy of similar size leads to a merger that erases all original structure. R5519 represents a fleeting, golden moment in a destructive process, a snapshot of cosmic violence crystallized into breathtaking order. This makes it an invaluable laboratory for astronomers. By studying the ring, they can trace the history of the shockwave, measure the rate of star formation in its wake, and understand how galactic gas behaves under extreme compression. It is a controlled experiment in galactic evolution, written across 100,000 light-years. Such precise accidents remind us that the universe's most stunning beauty often arises from its most violent moments, a temporary harmony born from a perfect disaster, where a single, well-placed strike can turn a spiral into a crown. A perfect ring of stars is a monument to a single, violent event, but some stars are born with a violence locked within themselves. Among the blazing, short-lived giants known as O-type stars, one stands apart as a true magnetic monster. Catalogued as NGC 1624-2, this star possesses the most powerful magnetic field ever measured for its kind. Its magnetism is not just strong, it is apocalyptic. While our sun's magnetic field creates sunspots and solar flares, the field of this star is thousands of times more intense. If you could bring a simple iron bar within a few million miles of it, the magnetic force would tear the individual atoms apart, ripping the bar into a stream of subatomic particles before it ever felt the star's heat. This titanic magnetism does not simply decorate the star, it imprisons it. All massive stars blow a fierce stellar wind, a torrent of charged particles streaming from their surface at millions of miles per hour. For a normal star, this wind escapes into space, but NGC 1624-2's magnetic field is so strong it acts as a cosmic cage. It captures and traps the star's own outgoing wind, forcing the superheated gas to flow along magnetic field lines and accumulate around the magnetic poles. The result is a permanent, seething shroud of the star's own trapped atmosphere, a glowing prison of gas that rotates with the star in a bizarre, magnetically controlled dance. This presents a profound challenge to our models of how massive stars live and die. Stellar evolution is a carefully balanced equation of mass, temperature, and rotation. An ordinary O-type star will burn through its nuclear fuel in just a few million years before exploding as a supernova, leaving behind a neutron star or black hole. But a magnetic field of this magnitude throws a wrench into the entire machinery. The trapped wind changes how the star loses mass over its lifetime. It likely slows the star's rotation dramatically, as the magnetic field acts like an anchor dragging through the stellar material. This altered rotation affects the internal mixing of elements, potentially changing what the star forges in its core. When this magnetic monster finally meets its end, the supernova explosion will be anything but standard. The collapsing core will have to contend with these immense magnetic fields, which could channel the explosion into incredibly powerful jets, perhaps creating a rare hypernova or an even more exotic magnetar, a neutron star with a magnetic field 1,000 trillion times stronger than Earth. The environment around the star is also sculpted by this force. The trapped wind creates a chaotic, magnetized bubble instead of a smooth outflow, affecting how the star interacts with its native nebula and any potential planets. It is a star that defies the standard script, a cosmic powerhouse whose very existence forces us to rewrite the chapters on stellar life cycles, proving that some stars are not just born to shine, but to dominate their surroundings with an invisible, crushing fist of pure magnetic will. That magnetic prison of a star shows the extremes of a solar system, but not all worlds are born into such a family. Adrift in the eternal dark, far from the warmth of any sun, is a lonely wanderer named PSOJ 318.5-22. This is a rogue planet, a world without a star, eternally free falling through the cold, empty space of the Beta Pictoris moving group. Its discovery was a surprise, a faint, warm glow spotted in infrared surveys that did not match the signature of any distant star. Follow-up observations confirmed the shocking truth. This object was not orbiting anything. It was completely alone, a solitary gas giant perhaps 6 times the mass of Jupiter, drifting like a ghost through the interstellar void. The question of its origin is a cosmic detective story with 2 compelling yet tragic suspects. The first is a story of violent exile. PSOJ 318.5-22 may have formed in a normal protoplanetary disk around a young star just like Jupiter did. But in the chaotic early days of a solar system, gravitational interactions between massive planets can be brutal. A close encounter with another giant could have flung this world out of its orbit, sending it careening into the black with enough speed to escape its star's gravity forever. It became a planetary castaway, ejected from its home and sentenced to an endless journey through the freezing dark. The second possibility is even more profound. Perhaps this object never had a star to begin with. It might have formed not as a planet, but in the same way a star does, from the direct collapse of a small, dense knot within a wandering cloud of gas and dust. If the knot lacked enough mass to ignite nuclear fusion, it would become a substellar object, a failed star known as a brown dwarf. PSOJ 318.5-22 sits right on the blurry boundary between a massive planet and a lightweight brown dwarf, making its true nature beautifully ambiguous. Its profound loneliness, however, is a gift to astronomers. Studying the atmosphere of a planet orbiting a star is incredibly difficult. The blinding glare of the star drowns out the faint light reflected by the planet, like trying to see a firefly sitting on a lighthouse lens. But with this rogue world, there is no lighthouse. Its own faint residual heat glow is all we see, allowing telescopes to analyze its light directly. For the first time, scientists can obtain a clean spectrum of a gas giant's atmosphere without the contaminating light of a host star. This makes it a pristine template, a Rosetta Stone for understanding the chemistry, cloud composition, and thermal structure of giant planets across the galaxy. Already, observations have revealed a turbulent, cloudy atmosphere rich in water vapor and strange, exotic compounds. This lonely world, a silent nomad in the dark, has become an invaluable guidebook, helping us decipher the secrets of countless other giants that do orbit stars, proving that sometimes the greatest insights come not from the light but from the shadows between them. While rogue planets wander the starless dark, a world within our own solar system displays a geometric precision that feels almost artificial. At Saturn's North Pole, a hexagon rules the sky. This is not a trick of shadow or a fleeting cloud formation, but a permanent, 6-sided jet stream, a colossal geometric storm that has persisted for decades, perhaps even centuries. It is a perfect honeycomb pattern etched into the planet's atmosphere, each side longer than the diameter of Earth, rotating with a slow, majestic cadence. Nothing else like it exists in our solar system. Jupiter's great red spot is a swirling oval. Earth's polar vortices are messy and shifting, but Saturn's hexagon is a polygon of almost mathematical purity, a cosmic signpost that defies our intuition about chaotic weather. The secret to this impossible shape lies not in solid structures but in the physics of spinning fluids. Imagine a pan of water placed on a rotating turntable. As the turntable spins, the water develops waves and patterns along its edges. Scientists believe a similar principle is at work on a planetary scale deep within Saturn. The planet's rapid rotation and the differing wind speeds at various latitudes likely create a standing wave pattern in the atmosphere, a stable ripple that gets locked into a six-sided shape. Laboratory experiments using cylinders of spinning fluid have successfully created similar polygonal shapes, including hexagons, proving that under the right conditions of rotation and shear, nature can spontaneously generate geometry. What makes Saturn's hexagon so breathtaking is its endurance. First glimpsed by the Voyager probes in the 1980s and later studied in stunning detail by the Cassini spacecraft, this atmospheric feature has remained locked in place, unwavering, for the entire span of our modern observation. It is a monument to stability in a system of unimaginable turbulence, a self-sustaining puzzle carved into the clouds. The hexagon is more than a curiosity, it is a natural laboratory. By studying its dynamics, planetary scientists can probe the deep wind structures and internal heat flows of gas giants, offering clues about the hidden forces that shape these worlds from the inside out. It stands as a humbling reminder that the laws of physics can write their most elegant equations not on a chalkboard, but across the sky of a distant planet, in a shape so perfect it seems to whisper of an order we are only beginning to understand. That geometric perfection in Saturn's clouds is a local wonder, but our galaxy is about to receive a visitor from its own deep past. Racing toward the spiral arm of the Milky Way is a colossal, ghostly structure known as Smith's Cloud. This is no wispy nebula. It is a titanic river of hydrogen gas, 11,000 light-years long and 2,500 light-years wide, moving at nearly 200 miles per second. If it were visible to our eyes, it would stretch across the sky with an apparent length 30 times greater than the full moon. Its destiny is a direct, unavoidable collision with the galactic disk, a reunion written in gravity. The cloud's true mystery, however, lies not in its size or speed, but in its surprising composition. When astronomers first studied it, they expected to find the pristine, primordial mix of hydrogen and helium typical of wandering intergalactic clouds. Instead, their instruments revealed a rich cocktail of heavier elements like sulfur and oxygen. These metals are the unmistakable signature of a stellar forge. They are only created in the nuclear hearts of stars and scattered by their explosive deaths. This chemical fingerprint tells a dramatic story of exile and return. Smith's Cloud was not born in the lonely void. It was ripped from the very heart of the Milky Way itself, likely torn away by a gravitational encounter with another dense object or a violent event in the galactic core over 70 million years ago. This cosmic fragment, enriched with the ashes of ancient stars, was hurled out into the galactic halo, and now, in a grand act of recycling, it is falling back home. The impending impact is a slow-motion spectacle of creation. In approximately 30 million years, this mountain of gas will plow into the plane of our galaxy. The collision will be not of solid bodies, but of diffuse matter meeting diffuse matter, a silent, titanic crunch felt across light years. As the cloud smashes into the denser gas of the galactic disk, the resulting shockwaves will compress vast regions of hydrogen, triggering gravitational collapse on an epic scale. The outcome will be a brilliant firestorm of star birth, a stellar nursery of unprecedented scale lighting up the spiral arm. Thousands, perhaps millions, of new suns will ignite in a dazzling burst of blue-white light, their formation seeded by the very material that was once ejected from their ancestral home. Smith's Cloud is a galactic fountain in action, a single droplet in a vast cycle where the galaxy breathes out and breathes in, expelling material only to gather it back again to build anew. It is a reminder that our galaxy is not a static island, but a living, breathing engine of constant renewal, where even the ghosts of its past return to fuel its brilliant future. From the violent grace of galactic fountains to the silent geometry of alien storms, our journey has revealed a cosmos of breathtaking and bewildering strangeness. We have charted the pull of unseen giants and listened for a single, perfect note from the void. We have witnessed stars that refuse to die and galaxies born without dark matter, cosmic diamonds forged in fire, and silent black holes hiding next door. Each discovery, from the icy wanderer Oumuamua to the perfect hexagon on Saturn, is a testament to a universe that consistently defies our expectations, crafting phenomena more incredible than our boldest fiction. These are not mere curiosities, they are the sharp edges of human knowledge, the places where our understanding of physics, chemistry, and reality itself bends and strains. Every unexplained signal, every impossible structure, is a question shouted into the dark, a challenge to the next generation of thinkers and dreamers. They remind us that science is not a dusty collection of facts, but a living, breathing story of inquiry, one where the most thrilling chapters are always the ones we have not yet written. So the next time you find yourself beneath a clear night sky, remember this: that tapestry of stars is not a static backdrop. It is a vibrant, chaotic, and deeply mysterious frontier. Within its darkness drift rogue worlds, within its light echo the ghosts of ancient collisions, and in its silence may yet be the whispers of truths we cannot yet conceive. Let that wonder pull you in. If exploring these cosmic riddles fuels your curiosity, consider subscribing to join us for more deep dives into the universe's greatest secrets. And we would love to hear from you. Of all the strange things we have uncovered together, which one captured your imagination the most? Share your thoughts in the comments below and keep looking up. The greatest mysteries are still waiting.